Well, thank you, and good morning. I live on the East Coast of the United States. Well, that's not true. In Columbus, Ohio, which is in the Eastern time zone of the United States. And I live on an urban farm in downtown Columbus. And I work for a nonprofit that works at creating opportunities for young people to experience, explore, succeed, and fail with STEM applied learning. And one of my great passions over the last 8 years has been doing on a larger scale what those four individual geniuses from Romania were doing, which is really exploring the future of soil health, the future of growing and sustaining urban populations with food in a way that makes sense, not only in large cities like Columbus or Shanghai or Singapore or even London, but also in private homes on the Mars, on the moon, and on Mars, because all of those things share a couple of things in common. The first is they need nature to produce resources for them in a set way, and we need to rethink the way we produce resources for nature. They also need to grow food in a controlled environment. And third, they need to redefine the way they think about food and food health. And so about 3 years ago, I really started actively exploring compost and what compost really is and what's required to make compost productive. And it's funny when Jake mentioned the freezing of things to make them more viable. That is precisely what I have spent the last 18 months doing, exploring how to freeze resources found here on Earth so that they can be packaged by robots and sent to other places and then reassembled using those robots and those frozen materials in a specific way to create food. And so I'm going to share my screen. I've never done it this way, Jake, so let me know. Give me a thumbs up, or Marcy, give me a thumbs up if you can hear or see the video. The video doesn't have any sound. It's just to give you an idea of what it is that I'm talking about.
Great.
So let me get to where I need to be. And now I can't find it. There it is. I just had that. Where did it go? There I go. Images. Week 2. There we go. How curious. Okay, so I am not as organized at 7 o'clock in the morning as I wanted to be. I just had all this up. How curious.
I would like to say that I know Jim is doing this deliberately because I have these kind of problems all the time, and he's trying to make me feel good that I'm not the only one. So
It's
thank
rare
you.
that I do.
Thank you, Jim, for deliberately having
There we
this
go.
problem. Oh,
I found it. I found it. Okay, so this is a video to give you an intro to where I live. So I'm going to share my screen here. Zoom, share screen, boom. Can you see that?
yes, we see it.
Okay. So this is my city. This is Columbus, Ohio, and this was taken Friday. And this will just give you an idea of where Mezzocello, which is my urban farm, actually is with respect to the city. And so what you're seeing now are the 24 Martian beds, the greenhouse facility, which I'll show you more of in a minute, and the bioreactor, which is below me and to my right. And that's me. It's my niece saying, hey, I'm above you. And the next video, to give you some context, is a flyover of the bioreactor. So in this video, can you see this one?
Not yet.
Okay, so I'm going to have to stop sharing. There.
Now we see
Yes.
it. Now we see it.
So this is a flyover of the bioreactor at Mezzocello. This tower that we're looking at, again, these are the beds, and I'm running summer camps here for 2 weeks. The next one starts tomorrow. There's my greenhouse with the Martian beds in them. This is a flyover of the bioreactor and the beds. So you can see how all the systems integrate. The tower, which I'll show you the layout for in just a moment, has produced all of the compost for these beds. Using this tower last summer, I produced 8 metric tons of compost. And so what I do with the compost is I accelerate it in that tower. And it's a proprietary process that I'm not ready to divulge to everyone yet, but I want to explain the base concepts for it. These are my raw materials. And you can see the bioreactor there. And that the 1,000 liters of water is above where the clock is. And then all of the chemicals are in the base. And all of this plant material and the plant material around Mezzocello provide the greens and browns. And the chickens and ducks, which live in this coop right here, produce all of the active manure that I use to start that process. From start to finish, that process takes about 21 days. And then I can pull it out, put it into the greenhouse, dry it out, and then into the freeze dryer. And I freeze dry it into basically 300 kilogram blocks. And my vision for this, and I'm going to stop sharing it for a moment. My vision for this is to learn how to freeze dry compost so it can be shipped in a 1,000 liter IBC to Mars, where robots will use this bioreactor tower and slip in the freeze dried materials, reactivate it with the reagent, and in 10 to 15 days, everything will settle down. They'll pull that out. All the water will be pulled out, and then another one put in, water added, and the process will reset itself. So if you sent this 18 months into the future, before humans got there, you could potentially have 200 of these blocks ready for planting, perfectly balanced. And my proof of concept happened this summer. And I'll show you when I say proof of concept, this is literally what I mean. In this above shot, pardon me, I've only had 1 cup of coffee. You'll see these white beds. Are you seeing those? Good.
Yeah.
So you may be wondering why those white beds are covered over in what appears to be plastic tarp. And that is because I discovered a flaw in my system while I was developing it with the kids. And the flaw is that there are nematodes that were shipped from Earth that came from horse manure that I was gifted. And you've heard the phrase, don't look a gift horse in the mouth. Do look a gift horse in the mouth, because the manure was fresh. Asking, how old is this manure? All of my compost is perfectly aged, heated to 55 degrees Celsius, and then freeze dried down very, very, very cold, and then reintegrated at about 40 degrees Celsius to jumpstart that process. So it was stable and mostly sterile of microbacteria. The microbacteria in the horse manure that I added because I needed a little bit more life in these beds. You can see the difference between the beds on the left and the beds on the right. The beds on the left are working perfectly. The way I designed the compost from the bioreactor to work, the beds on the right all contained a dangerous type of bacteria and microlife and fungal life called nematodes. And they destroyed all the roots of the plants I was growing. And as you can imagine, this is a worst case scenario on Mars, that the soil that I sent will destroy all life that you try to plant in it. So I'm glad I tried it here. And so I need to show this one more time. What I ended up having to do was, this is the bioreactor down here at the bottom. I had to create a control group of tested soils to identify what is it in that soil that's causing all the problems. And so we just pivoted my summer camp because, frankly, I had access to kids. And so we pivoted my summer camp to be here we go, share screen, to be an opportunity for these kids to take the bioreactor and all of its contents and test them on Mars. So this is a couple of shots of the camp I was running. The top photo is another shot of Mesocello with the bioreactor in place. You can see the greenhouse and the garden beds to the right here, garden beds to the left. In the middle, you can see the test simulation that I had of one of the byproducts from the Martian bed product and the bioreactor. And one of those byproducts that was an unintended byproduct was a new fertilizer that I am currently working on a patent for, called Eden's Ghost. And Marcy or Jake, can you imagine why I decided to call it Eden's Ghost? Take a guess, please.
It's the leftover from the Garden of Eden. The Garden of Eden died, and this is what's left.
Very, very close. Yeah, I call it Eden's Ghost because Eden was either paradise or it ended very, very poorly. And so what we ended up doing was we realized Eden's Ghost is really good at growing food, but only in small amounts. And so we took the Eden's Ghost and we realized just 100 milliliters of it suspended in 30 liters of water was enough to make everything grow. Anything more destroyed everything in that bed. And so in the middle of these two photographs we're looking at, we see the kids applying Eden's Ghost and the bioreactor substrate to a test bed of 12 beds. And if I zoom in on this, can I zoom in on this? You can see them meticulously testing with the robot and the planter, and you can see the beds that did thrive and the beds that did not. And so I was running 3 concurrent experiments over the last month. What will it look like in pure Martian regolith? What will it look like in absolutely repurposed compost made from nothing more than grass clippings and shredded leaves? And finally, what it would look like on Earth with substrates that the kids tested all of the soil components: pH, temperature, ambient light, raw material, and a base substrate. There are 3 substrates here that these kids are testing for me of what the Martian colony or the family in Singapore that wanted to build food from a modular system like this would experience. And from those 2 test groups, the isolated test group, which is the pictures above at the Past Innovation Lab, with their robot doing everything, and my beds at Mezzocello with the bioreactor in the background, and they balanced everything. They learned to balance the pH by either adding alkalinity or acidity. They managed to test for micro fungi and bacteria using a handheld 1000 magnifying microscope that plugs into an iPhone. And they learned to test the temperature, the structure, the water control, and everything through a series of test runs at Mezzocello over the last week of that 2-week camp. And they built a robot that does very much what the Martian gantry did here on this test bed that I improvised on the last day when I realized I'm doomed because half of my beds will not support life unless they have been bred to not be affected by this particular species of nematode that can be found in what's called green manure from a horse. The woman that gave me the 1 metric ton of manure dug it from the top of her pile, not the bottom. And I, being a very bad scientist, didn't ask questions. And so, lesson learned. This system is fallible. You have to give it precisely what it wants, or it will doom you. And that's why I named the substrate coming out of the bioreactor Eden's Ghost. Because either it's going to work perfectly, or you're dead. Plain and simple. And so, that's what I've been doing for the last year, Jake. I've been perfecting this system. And the upper water is fed by solar-powered pumps from all of my rain barrels, which are also 1,000 milliliter rain barrel IBCs around my property. And the pump pumps water underground to the bioreactor, up those 2.8 meters to the top, and puts it in. And there's a sensor that tells me when it's full, and that turns the pump off. And then on the side of that pump is where I mix my 3 substrates, set amounts of beer, ammonia, or urine, depending on what you have access to, and what your health department will allow you to work with. And Columbus City Health Department frowns on using human urine in foodborne experiments. So I just used synthesized ammonia and cola and water. And I found the perfect mixture of that, the perfect temperature for that, the perfect device to mix that over 21 days. And it gave me 2 streams of product. Compressed compost ready for planting that I had freeze-dried by a company here in Columbus that does that. And I'm working on a grant to get a freeze dryer of my own, because I learned I can either freeze dry the packaging, or I can freeze dry the grass clipping and the shredded leaves, and then just send them to Mars, because it works. If you reheat and bring all of those materials back to atmospheric pressure of around 28 degrees Celsius, that process of creating Eden's Ghost and the compost block is exactly the same. I did not know that before I started doing this. So I'm working on that product now. But the Eden's Ghost is ready to go now. I can start, I'm working on getting a patent on that, a vendor's license on that, an EPA regulation license on that, a City of Columbus Health Department license on that, because make no mistake about this, it is a biohazard. It is dangerous to handle. It will either sterilize everything in its surroundings, or it will, if you use properly and mixed properly, it will make really, really, really good environments for life. So that photograph that I showed you of those 3 kids that were testing soil, they were testing exactly what the, I shared the wrong thing. They were testing exactly what they needed to understand And so that's pretty much my presentation. I can answer other questions, but I can't show a lot more on this process yet because I'm actively in the process of building that. But I can answer questions.
No. Don't give away any trade secrets. I don't want you to have to kill me. Um, this is an incredible story. This is just an incredible story. And I think the most incredible part is not what you've done, but what you've overcome. So you're using the horse manure, which is a wonderful idea, and things are dying. What did you do? How did you react? And how did you discover the nematode problem?
Well, the first thing I did, mind you, Jake, I'm in the middle of a camp where I'm supposed to be the subject matter expert on this. And I've got 12 kids that are looking at all the plants that are dying. I'm like, well, the very first thing any good inventor does is acknowledge something's wrong and then start isolating for controls. What is going on? What's different between the soil where the potatoes and the peppers and all the other brassicas, brassicas are just broccoli and kale and onions, are doing really, really well. So the kids just started making observations. What's different about this soil and that soil? And what I learned, is that the indicator species in the soil were out of control. The centipedes, the pill bugs, the fungus, all of that. Because what I didn't show you is that the compost is layered in the bed, which is 1.5 meters wide by 0.75 meters deep, or long and deep, and then 30 centimeters deep. So I had to dig 24 30-centimeter deep, basically, what are they called? What do you call it when you bury someone?
Grave?
Grave.
But you were doing
That's
a
English
probe.
word.
You were doing probe.
I was digging 24 of them. And I live in downtown Columbus between 3 trauma hospitals. And the light flight flying over and the police helicopters reported me while I was doing this. You should probably check out this property. We think there may be unmarked graves. So I got a visit from the police halfway through this process. Why are you digging what appear to be graves and look to us to be graves? No. That's the soil I inherited from 150 years of occupied, built urban environment. And I'm replacing it with soil that I'm actively building in this robot behind me. And the police were like, that's a very specific answer to that question. So they came back a couple of days later, and sure enough, there were mounds this high, 20 centimeters high above that grave that were going to rot down. So I had all these beds, and the kids were testing it, and they're like, the indicator species are telling us something's not right. So they just started doing controlled research. I had been teaching them, good scientists observe, make a hypothesis, look at that data, and then see what it is. And it was they who discovered that the indicator species were eating the bad nematode, which in turn was eating the bacteria, which were feeding the roots, which were in turn then rotting the roots, and the centipedes and pill bugs were eating the rotted roots. That's the ecosystem I had invariably, unexpectedly, accidentally created. And adding the Eden's ghost only accelerated that process. So once we realized that, we came up with a solution, and it was, ironically, the solution that's happening on our planet right now. You need to create an uncontrolled greenhouse effect over these beds to sterilize them at above 50 degrees Celsius for 2 weeks. Turn it, sterilize it again for a week, and then come back to it. And that's what I did. And I'm very happy to tell you that as of this morning, that's back to being pure compost. And so I have a camp, surprise, starting tomorrow with 8 beds that are perfectly balanced for what I intended Mars to have. And we'll start again, and we'll do a new control group, and we'll monitor it like good scientists do. And so how much time do I have? Oh, I only have 4 minutes.
No. You've got 15, 20 minutes.
So the camp tomorrow it's a 2-week camp, 3-hour blocks. The first hour in the first week, the first block is all engineering. How do you build a bioreactor? How do you build systems for growing food anywhere? What's a raised bed? Why does it work? What is, how do systems for monitoring the soil pH, the soil substrates, the water, the light, the all of the ingredients in Eden's Ghost, how do you measure that out and build systems that will automate that for you? In the afternoon, how do you test for it? What's an ecology? What's an indicator species? How does food grow? How do you digest food in your body? What is the microbiome in your body? How is the microbiome in the soil similar to the microbiome in your body? And if you don't know what the microbiome in your body is, you really should. And you do not digest food. This is something I learned over the last 18 months doing research for the bioreactor. The bacteria in your body digest food that you chew up conveniently, like I have to shred the food for the bioreactor, and then the base bacteria in your intestine eat that, defecate that. Smaller bacteria eat that, defecate that. Smaller bacteria eat that, defecate that. And there's a symbiotic relationship of bacteria in your gut that produces food small enough to enter your bloodstream. Yeah.
Okay, I'm imagining this on Mars, and you bring everything out there. How do you control the bacteria in the humans that you're transporting to Mars? And might they not do the same thing as your horses and
Yes, they
ruin
would.
everything and kill themselves?
Yes, they would. And so what they do, and what they do on ISS, what they do on the ISS and what they will do on Mars is they will freeze dry human waste. And that will destroy the non-beneficial microbes. It'll destroy all the microbes. And then they can systematically, and what I had to do, basically what I just did, was they sterilize it and then reintroduce the bacteria they actually need. And they won't do it. The robotic sentries will, and balance it out. And so that's the answer to that question. I would have sterilized that horse manure like I do my chicken manure. I know better. I can't use chicken manure directly in the garden. It contains dangerous micropathogens that need to be handled. I just didn't ask the right questions. So I learned that lesson, and every good inventor and scientist learns from their mistakes first and then doesn't replicate them. So I need $4,000 for a freeze dryer, or I need to get the company that allowed me under the table to use a food grade freeze dryer to test my thoughts and my theory of action. And so that's how they would do that. Simple answer. That's how your body does it. It heats it up. It runs it through sulfuric acid to the place where anything bad in it is already destroyed. And the environment in your intestines is already balanced, unless you're eating really bad food, to process it for you. I just didn't reverse engineer that process faithfully enough. So that's a great question. And I'm going to answer that question exactly that way next week. Because the second part of that week is ecology. And then the second week is all robotics, where we'll build robots and sensors to do precisely what you just asked how I'm going to do. And the second afternoon is all automation. Because the more automation and robots I have, the better. And one of the ways that we will test Eden's Ghost is we'll put a sensor down in it that tests turbidity, light, heat, and acid. And when those levels are perfect, that is ready for use. And all of that's going to be built in an Altoid box, like a mint box, that's been sealed and treated, and the sensors are rated for that kind of acidic environment. And the kids will just build it together and write the code in Python, build an Arduino chip, and do it. Because if they don't do it, and they don't fail, and they don't try it again, none of us are the better.
So the raw materials available on Mars, I don't know much about Mars, to be perfectly honest. I think I don't know whose theory it is, but the constancy of matter. I know energy is involved in there too, and there's energy on Mars that I guess can convert things into matter. But
yeah. I have failed you there.
Will,
There is no biomaterial on Mars. It
the
has to be
what?
brought. There is no biomass on
Okay,
Mars.
that's what so you can so the only way to grow a community on Mars
Is
never become another Earth unless you bring enough material from Earth to support life there too.
Marcy, that's a whole different, that's a whole different science and technology. That's
Yeah,
engineering the
I'm
planet's
thinking what you
ecosphere.
want, everything that you're doing is for that purpose. So I'm thinking like, will
Eventually.
this work?
Yeah, that's terraforming. I'm just building domed communities that can grow food that are pressurized. So the reason I wanted to build the bioreactor is because one, I wanted to test if I could make compost faster. I can, and it's viable as long as I don't impregnate it with dangerous pathogens, ironically, from Earth. The second thing I wanted to test is if I could remove all the water, how much lighter would it be? Because it's $10,000 US dollars to ship every pound from Earth to Mars. So the lighter I can get it, the better. And that proof of concept worked beautifully. You can freeze dry grass. You can freeze dry brown material, compress them, ship them. Robots can put them back together, add the chemicals in the right amount, test the Eden's ghost, and go. Make it again and again. Because you could ship 100 times more biomass if you dried it out than if you could shipping it with the water still in it.
So what would happen if you tried that on Earth in places that are deserts, like places that might just create the nidus and the critical mass of plant life to create a forest?
Come back for phase 3 of Mesocello and the bioreactor. That's my next experiment. Going someplace, basically building a bioreactor on a concrete lot in downtown Columbus with raised beds that the bioreactor will take input from the community and just build the compost, compress it, put it into the beds, test it under that dome that I built for the test beds at the Past Innovation Lab and see if it will work. Because if it works there, it doesn't matter where you are. You're going to have to build some sort of pressurized enclosure around it because the plants need the right amount of moisture, the right amount of oxygen and nitrogen in the atmosphere, the right amount of pressure. So that's the answer. Phase 3 coming up.
Yeah, I read a story literally within the last week about somebody in India who started by planting one plant a day in a desert, and 37 years later, there's an entire thriving forest with rhinoceros and lions or tigers, I don't know, whichever,
Yeah.
or both.
I mean,
So
nature will
why
do it if you
cannot,
give it the right
why
tool.
can we not do that a little closer to home? Because there's so many uninhabitable, or maybe not uninhabitable, but like unpalatable places to live in the United States that could become, or not in the United States, in the world, that could become much more inhabitable.
That's a great question. And it comes down to intention, action, and impact. People don't want to put the work in, or the space isn't really large enough to get the biomass that you want. And our culture regularly throws biomass away. The kids before me were just talking about this problem. I just expounded on this problem, added robots and a grant. But it's the same problem. We need to retrain people to think about where food comes from, what food really is, and how we actually interact with the ecosphere around us to make food. That's my goal. Phase 3 is how we do it where people have nothing. And can we do it quickly?
Jim, you brought up a very interesting thing that I've read a lot of books on gardening, and they talk about, the pH and adding nitrogen and phosphorus and stuff like that. When you talked about the indicator species, a way of looking at the, little things in there as so what did you do? The students did surveys and started counting the number of, worms and beetles and.
That's precisely what they did. I gave them 8-centimeter rings and they threw it down, and for 1 minute they counted all the species they saw pass through that ring, and that gave us a distributed count of how many were in there, and it was a lot. So obviously composting was still going on and there was something bad. And so we watched YouTube. We all went to YouTube University. What do these species eat? And the answer came up to be a dangerous pathogenic form of nematode. And so sure enough, when we looked at it under a microscope, there it was. All the indicators of plant health were there for that species. It needs to be heated to above 55 degrees Celsius for a length of time to destroy its environment. And microbacteria will come back up into an environment where the nematodes aren't destroying the ecosystem they live in. And the indicator species disappeared because there was no food for them to eat there. That's how I found that out.
You know, I don't know personally how you feel about the last project you did. And I don't think it was a failure. I think it was an incredible success.
Oh, absolutely.
I feel sorry for the kids coming this year because they're not going to have this wonderful opportunity to really discover what's going on. Things will work perfectly, and that's kind of boring. I think your last group had a life-changing experience.
Well, and that's a great, thank you for that, by the way. But I think we learn more from failure than we do success ever. And so there will be failures. There will be failures because we spent so much time on the last camp solving the nematode crisis, which is what the kids called it, that we didn't get to some of the robots. And so there'll be failures for the robots because we didn't get to test a lot of the coding they did. So the kids, there's an opportunity. Every opportunity gives you either the chance to succeed or the chance to succeed through failure. And so I don't know what's coming, but I'm excited for it and I'll report back.
You only learn through failure. When you succeed, you think you're a genius. And no, I mean, I've done it. You succeed. Oh, I'm a genius. I'm wonderful. You didn't learn anything. It's when it doesn't work. So I think those kids had a fantastic experience. And can you imagine when they're applying to college or applying for a job and somebody says, well, what have you done interesting in your life? And they're going to talk about your project. That's amazing. Just amazing.
My only regret, Jake, and I would like to talk to you, Aaron, and Sherilyn about this. I'm getting requests on chat if I could make this camp virtual and walk kids from around the world through it.
Yeah.
I would like nothing more than to do that. I just don't know how to get that started. But yes, I would. I can't type the answer out of the bill, but I would love that. And the last thing I want to say is at the end of the camp, I interviewed all the students and the knowledge, firsthand knowledge they got about ecosystems and farming was outstanding. And one of the kids had come into the camp wanting to be a tattoo artist. That's his career. And now he really wants to be a tattoo artist, but I might also want to be a microbiologist and a pathologist because I wonder, why do tattoos get infected? And now I have insight into why. My job is done. And I loved that. That was the greatest gift to me, is exposing kids to the idea that knowledge is power. No matter how you apply it, that's your genius. Apply it the way you need to, but never forget knowledge is power. Every piece of knowledge is power. And that's what I love about gift. I get to see kids being amazing just because they can and they want to. And that's a gift for me. I love being a part of this for that reason. I thought about all these kids and I can't let them down. We have to keep pushing and being better and better and better. And so that's why I did what I did.
So Jim, let me ask you seriously, would it be okay if people contacted you around the world and asked you,
it would
support and help?
It would mean a lot to me.
Then how can they reach you? At Best Foundation? What would be the best way?
Mezzocello.org. I'll put it in the chat. You can share it out, or I can share it on YouTube as well. But mezzocello.org, I just relaunched that website for this kind of interaction. Do you mind if I share screen real quick?
No, please. That's what you're here for.
Let me just, I don't know how much time I have left. We've done a lot of talking.
You have 5 minutes. You're in good shape.
Open.
Somebody from Saudi Arabia wants to join your camp.
I saw that. So I just redesigned this. Why are you not giving me what I want? Hold on, guys. Technology is really failing me this morning. It's telling me I have a critical error in my code. There it is. Share screen. So this is my website, mezzocello.org. And here's the data capture. It's unstable this morning. This is my data capture form that the kids used. And it just collects data on the back end of all the variables they wanted to collect. Who are you? What was your team name? Where are you collecting? Are you collecting from the test bed or the actual Martian beds? Tell me where. Give me the exact GPS coordinates of where you were. What was the pH? What was the temperature? The atmospheric temperature, the wind speed, other notes. And then they submit that data, and then we track that data. So there's no reason I couldn't do this virtually. I just need to add a sign-on form so I know who's reporting, what they're doing, and then the other piece of this, I can't see the top of my form. The other piece of this are image capture. Share with me pictures so I can trace your data. I'm ready to do this right now. The only thing I need to do is build an API with a Google map on it to track where they are. But first, we need a cohort of 20 students that are willing to sign up on this, and a closeoff time. Oops, I'll stop sharing now. And I don't know what I'm doing wrong. I'm hearing feedback.
Trust me, Jim, you're not doing anything wrong.
Well, I'm ready for that cohort. I just need a little structure.
Let me just end on one more point. If anyone is watching and they are a foundation or a company or an organization that would like to support Jim's work, I'm sure he would be very grateful and interested in talking to you. So while we're very interested in getting more students involved, it takes funding, and Jim would love to get that. So he may be too proud to ask, but I am not. So
I'm not, actually. And I failed to mention.
If anybody has found this interesting, and I'm sure that you did, and you'd like to help and support him at any level, he would be very, very interested in talking with you.
I should add, Jake, that the bioreactor itself was funded from a grant from the Ohio Farm Bureau, because I convinced them that teaching kids how to feed themselves using agricultural principles and technology was a good idea. Because if 80% of our population by 2050 will be living in cities, it isn't about farms anymore. It's more, tell me you're a farmer without actually telling me you're a farmer. What careers do you need to have to successfully grow food in any environment? And so that was that grant. But I am looking for other grant opportunities. To exactly your point, I need to expand this mission to the world.
Great. Excellent. Excellent.
And thank you for the opportunity.
And the world needs you to expand it also. I think this is wonderful. Thank you, Jim. This is just fantastic.